Hello, I'm Bill Leipold, and welcome to this edition of Breakfast at the Barracks. Joining me is Nick Vorsa, Director of Philip B. Marucci Center for Blueberry and Cranberry Research at Rutgers New Brunswick. Nick, welcome to the show.
Thanks for the invite.
I appreciate it. So, cranberry and blueberry research, so tell us a little bit about what that means.
Well, blueberry and cranberry, which are quite unique in that they're native to North America. Most other crops that we actually imported into North America. The crops have been domesticated only recently in the last 100 years or so, and just like any other commodity, agricultural or horticultural commodity, they have their myriad of pests that would like to eat them as well, such as insects and fungi.
All right.
And so our mission there at the center is essentially to develop systems where growers can economically grow these crops without, while at the same time minimizing the use of inputs such as chemicals, pesticides, and so forth. And my area happens to be breeding and genetics, so the logical objective there is to develop varieties that are more resistant to disease and insects, so we can use less sprays and that sort of thing. And we also have two other faculty members, one Dr. Peter Udemans, who's in plant pathology, working with the disease of both crops, and Dr. Cesar Rodriguez, who's our entomologist, and they are working on systems and methods and technologies that will enable the growers to grow these crops with the best management practices.
So let's start with some basics. Where is the research center located?
The center is located about 75 miles south of the New Brunswick campus in Chatsworth, New Jersey. It's actually about 10 miles outside of Chatsworth, but it's right smack in the middle of the Pine Barrens.
So let's talk about, we often hear about cranberry bogs from the Ocean Spray commercial, or we hear about blueberry patches. Right. So what does the center include? Does it include a bog and some patches, or how is the center set up?
Well, the center, as far as land areas, it's probably about, I think we have about close to 400 or 500 acres. But as far as the area that we use, we have about 20 acres of cranberries. Those are partitioned into 20 half-acre beds or bogs, and 2 5-acre beds. Blueberries, we have about 30 to 40 acres of various plots. The USDA also has 2 scientists there, ARS scientists, Agricultural Research Service, that carry out breeding work on developing varieties that are will be hopefully broadly adapted, that can be used not only here in New Jersey but nationwide.
So talk to me about this breeding thing, because it sounds to me kind of strange and scientific in some way. So do you dissect it in a lab and then go out and try it? Like, how do you go about your research? Well,
it's a process of trying to develop plant progenies or populations from crosses that have genetic variation, and what we do is we try to essentially generate families of progeny, both in cranberries and blueberries, and put them out in the field, and then evaluate them under various conditions, including disease pressure, insect pressure. In New Jersey, actually offers one of the best sites for breeding woody perennials, and that includes tree fruits as well. Both blueberries and cranberries are woody perennials. They're native to New Jersey. As a matter of fact, the first breeding program was carried out by the U.S. Department of Agriculture in Beltsville, along with Elizabeth White here in New Jersey, in White's Bog, now near Pemberton. And what Dr. Frederick Coville, who initiated the process with blueberry, that is, he would take the plants back to Beltsville, make crosses, and then send the seedlings back up to New Jersey, whereupon they would evaluate these over a number of years, selecting those that are the most hardy, the most flavorful, probably fruit size increased a little bit as well. And also in New Jersey, there was a devastating disease in cranberry at the turn of the 20th century, around 1910. A disease called false blossom decimated the industry here. There used to be about 13,000 acres in cranberry. And that these, as the name implies, produces a false blossom and doesn't set fruit.
All right.
And that took a terrible toll on the industry, and many cranberry beds that were being harvested for cranberries went out of business. And today we only have about 2,800 acres. And what, through research, I believe it was through the Brookhaven Research Center, they identified an insect called the blunt-nosed leafhopper that vectored this phytoplasma. It's a disease.
Right.
And with the use of pesticides, and way back then it was DDT actually that probably saved the industry here from going out completely under, but they were able to control the disease. And really nothing has changed from that standpoint, because through time, new diseases, new insect pests continually evolve and emerge. And so our center there is to try to stay a step ahead of the process that could decimate the industry with a disease.
Let's talk about this for a second, because you had said at the beginning that you had put them underneath disease pressure and insect pressure. Do you take the current disease and try to manipulate that while you're in the field? How do you kind of go about doing disease pressure and insect pressure? Well,
I'll take, for example, cranberry, for example. New Jersey, of all the growing areas in North America, which is largely where cranberries are grown, has the highest fruit rot pressure anywhere. As a matter of fact, the very first publication of the New Jersey Agricultural Experiment Station in 1880, the first bulletin was on cranberry fruit rot and its cure.
Oh, wow.
And so we're still battling that disease.
Well, what is fruit rot? So let's...
Okay, well, fruit rot is largely fungi that will essentially consume the cranberry and make it inedible or soft and not saleable.
So we've been kind of dealing with this for 105 years.
Exactly.
All right.
The program at the Marucci Center has essentially, as far as this particular disease, is and it's actually caused by over 15 different fungal organisms. So it's actually a disease complex. Dr. Peter Udemans published some papers on the dynamics of those organisms, but they are the most severe threat to the New Jersey the cranberry industry here. And so in my program, we're trying to develop, we've identified from what we refer to as germplasm.
I was going to ask that question. What is germplasm?
Germplasm is essentially a collection of plants with the ideal would be with the collection of plants of a particular species, in this case cranberry, the American cranberry, that we collected. When I first started in 1985, I went out and what's nice about cranberry, it's native to North America.
Right.
It occurs largely east of the Mississippi. So we went out and collected wild cranberry and brought them back to the center, and we have this collection of cranberry plants from Delaware up through Canada, out west to Minnesota.
Oh, wow.
And we keep this collection in the field. And so what we can do is we can evaluate this collection of plants, which is essentially a collection of genes that are found in cranberry. And hopefully we have the majority of the genetic diversity represented in this collection. And so what we did a few years back, we eliminated any fungicide sprays to allow the fruit rot disease to develop to its full maximum. And with the severe disease pressure that we had, we were able to select out a number of varieties that have what appears to be fairly good resistance to the fungal disease. The problem is that these particular types may not be the most productive. And so what we're trying to do is we're trying to cross these with the more productive varieties and hopefully combine the best traits of the resistance and of the more productive varieties that may not be that are not disease resistant.
So how do you do the crossing? So you take one blueberry gene with another blueberry gene, and you talk about crossing. You make it seem so simple in your conversation.
Well, it's really, we use the process of nature. We use the flowers. And what happens in the flowers is that the chromosomes of the two parents that went into that individual essentially go through a process called meiosis. And this process leads to pollen and egg. But what this process does, it really reshuffles the genes. It recombines the chromosomes of the parents, and you get new combinations that didn't exist before. And so what we do is we try to stack the deck, so to speak. I liken it to playing cards, is that you shuffle the deck of genes, and then you try to select a hand that's better than the one you currently have out there. And but we're talking about many genes in plants like cranberry. There's probably, it's estimated that there's over 20,000 genes in there. So we're trying to develop a constellation of genes, if you will, that are superior to any of the varieties that we currently have, and combining the trait of resistance to, say, the fungal diseases, along with the traits that will make the plant productive, so that the growers can be economically sustained with a good crop.
Now, we talked a little bit before you came on camera about the conversation that weather plays into this. So how does, I mean, they're outside, obviously, in nature, so does it matter whether or not it rains more, it's dry more, snow more?
Well, that's a good point, because that's what I alluded to before. New Jersey is probably has one of the best environments to select for both in woody perennials, including blueberry and cranberry. And in contrast to annual crops like corn and wheat and soybeans, where you're really only looking at their adaptation from maybe May through August or September, cranberry and blueberries are out there year-round. And New Jersey, at least I think, that we can have a winter anywhere from a Michigan winter to a North Carolina winter. Likewise, like this summer, we had extreme conditions. We had a lot of rain in August with the hurricane, and in July we had 3 or 4 days that reached over 100 degrees. And these plants have to be adapted to all these possibilities year-round. And so if we have varieties, and it's a long-term process, it's not a very quick process. A number of varieties that we released just in the last 6-7 years, the crosses were made in 1988, over 20 years ago. And so we put these plants out in the field, and over a decade or 5-6 years to a decade, if we can identify those that have been consistently productive, that have fewer disease and insect problems, we essentially have imposed our selection on those, and hopefully we can arrive at a plant that's is going to be an improvement over the current the varieties that have existed previously.
You know, you're doing some fascinating work, and I want to, you know, on behalf of New Jersey, I want to thank you, because the blueberries are always great, and without your research, we appreciate that. So
thank you.
We'll be right back after this. So. Welcome back. Joining me is Lara DelMolino, Director of Douglas Developmental Disability Center at Rutgers New Brunswick. Lara, welcome to the show.
Thank you. Thank you.
Why don't you tell us a little bit about the center and its mission?
Okay, the DEDC has a 3-part mission. So the primary part of the mission, which is the most obvious, is to serve people with autism and their families, so from young children to adults who have autism. The other parts of the mission are embedded. The other is to provide training to professionals and Rutgers students who want to learn about autism and its treatment. So it's on campus. There's an opportunity to do that. And the third part is like a scholarly academic mission. So we have faculty who are very active in doing treatment research about autism and writing about it, lecturing about it, and writing books and journal articles and such.
Well, let's talk a little bit. I know autism is a spectrum, but can you talk to me about what autism is and why it's a spectrum?
Yes, the spectrum of autism spectrum disorders really represents a range of behavior that goes from sort of very severe and involved to mildly severe. And we're talking about a triad of symptoms.
Okay.
So it's children or adults who exhibit problems in 3 areas. The first, which is sometimes the most obvious, is a lack of communication skills. Now that can range from a child that doesn't speak at all, so it's completely non-vocal, nonverbal, to a child or adult who speaks very well. Their speech is good, but they don't use their speech to communicate in typical ways.
Okay.
So that related to that is social deficits. So again, children who may be indifferent to other kids, so sort of not even aware that there are other kids around, showing no interest in them, to children or adults who, on the milder side, have an interest in other people but don't know how to relate to them, like don't really know how to have a friendship or be reciprocal. And the third area is what we call sort of restricted interests and repetitive behavior. So the most obvious, again, are these repetitive behaviors like children who flap their hands or spin around and do that sort of instead of other types of play.
Okay.
At the higher end of the spectrum, you see people who have like very narrow and detailed interests in things like the weather, the solar system, door hinges, any sort of unusual topic that takes all of their time and interest and energy. And it's a very narrow focus.
One of the things that you kind of talked about it, reminded me of one of the characters on Parenthood.
Okay.
Like Max. So does Max fit into the spectrum in terms of a character?
I've heard that, but I don't know the show.
Okay.
But yes, I have heard that, that show is one way where the media is really highlighting what's a very commonly known set of characteristics.
So when a family, does a family seek you out? Do you seek a family out? How does that connection happen?
At the DDC, often the largest part of our program is the school program.
Okay.
So children entering the school system at the age of 3 in New Jersey most likely have had a diagnosis of autism already.
Okay.
So often it's at the time when they're looking for school, or the public school is working with the family to see if they have appropriate services. Often that's when the parents reach out to us, or a school district will reach out to us. We do have an early intervention program where we're in the home with children from birth to age 3 that have been identified through their early intervention system in the state.
Okay.
So those referrals often come through primary care physicians, pediatricians, and to the state looking for early intervention providers.
So let's talk a little bit about this. So when a student comes to you, how do you engage the student in a classroom? How do you teach the student? I know you're really around teaching ABA. I don't know what ABA is, so can you tell us a little bit about that?
I'll start there with what
great.
ABA is, because that's one of the things we teach undergraduates, Rutgers undergraduates and graduate students, is what is the ABA and why is it important to know about it. ABA stands for Applied Behavior Analysis.
All right.
Okay, so the behavior analysis part, if you go back to college level learning, where how do organisms and people learn things? Why do they behave the way they behave?
Correct.
Understanding that from an experimental perspective, understanding how you can change behavior, that's behavior analysis.
Okay.
So analyzing behavior by looking at the interaction between a person and its environment, or an organism and its environment. Okay, it's very scientific, it began with lab work. Applied behavior analysis is the science of saying, okay, what do we know about how behavior happens? And let's apply it to behavior that's important in society. One of the reasons why it's so common now, we talk about ABA in treatment of disabilities and treatment of people with autism, is because we don't have a medical way to treat autism. So the only thing we can do in autism is say, why are they behaving in this way? How do we want them to behave differently? What do we need them to learn that they're not learning from their natural environment? And how can we change the environment?
Okay.
So it's really about scientifically examining the person's environment and making sure their learning environment is going to support learning.
Okay.
Because a typical child growing up without autism learns to talk, and they learn to communicate, and they learn to connect with people socially. A child growing up with autism doesn't learn those things from their natural environment.
So I'm assuming at this particular point, too, that ABA would also be the interactive with the family. So it's just not a student in the classroom.
Absolutely.
When you say environment, I'm thinking it's a global kind of context for them.
Correct. The research on how effective ABA is as a treatment or as a means of educating kids with autism from the very beginning, decades and decades, show that parent training is fundamental because it's about changing the way the world interacts with this person, this child, so that they can learn from their environment.
Right.
So in early intervention, we're going into the homes, we're working side by side with the parents, saying, this is how to help them speak to you.
Right.
This is how to help them learn to play, because what you're normally doing as a parent is not enough for a child with a disability. It's not that it's not enough, it's just the child needs something different.
So it sounds to me as though while we're helping the child, it's also helping the parent deal with
Correct.
and coping with, and helping them to understand some of the emotions.
Correct.
That come with, I expected to be a parent like this, now I'm doing it differently.
Right.
And what does that mean for them?
Right. The impact of autism on the family is actually a theme of research that's been going on at the DDC for decades.
Okay.
Sandra Harris, who's the executive director of the center, has done lots of work understanding parents' perspective and siblings also, what it's like to have a brother or sister with autism. So one of the things our center does is offer sibling support groups.
Okay.
And graduate students from the psychology department work and run these support groups and help young children growing up in a family where there's autism understand that there's other kids who have a brother or sister that does the same things my brother or sister does. And we help them learn coping and learn how to talk about it and how to respond to their friends who might make comments. So that's another important thing that we do.
I'm going to ask a strange question. So in a family that may have 3 or 4 children,
Yes.
does autism show up uniquely in one child? Is it uniquely in 2 children? I mean, how does it play out within a family with multiple children?
There are, we know, unfortunately, many families who are affected with multiple children with autism. And the research does show that there is a very strong genetic component. Right. So a couple that has a child with autism is more likely to have more children with autism. We also see, the technical term would be the broader autism phenotype, which is sometimes in families you see people that don't quite have autism, but they have some of the characteristics. So you start looking up the family tree and through the siblings and say, oh, that's sort of like this uncle or this cousin who had this language problem or was, a little more isolated socially. And so you see that in families as well. So traits that don't reach a diagnostic threshold, but suggest, some sort of connection in the family.
A lot of media coverage has been around autism, especially around the diagnostics numbers. So can you give us a little perspective on kind of, is it 1 in 50, is it 1 in 60, is it 1 in 100 kind of, and how do we know that, and how does research uncover that?
Well, I think that is a very challenging body of research to digest. The numbers in New Jersey, for example, have been, 1 in 90 in New Jersey, and that's, 1 in 90 on the autism spectrum, which could mean a mild form. That might not be the same figures that you'd see in other states. The media and the scientific community has talked about, is there really an increase in autism? Because obviously those numbers are higher than they were years ago.
Right.
Or are we just getting better at recognizing it? Is there more awareness? The best research we have tells us that both are. There is some level of better recognition, more, awareness, and so people who might not have been labeled before are receiving that diagnosis and getting better services as a result of this awareness. But there also really does seem to be a true increase in the incidence of the disorder, and people really aren't sure why.
Now, are more states likely to have an increase based upon their location, based upon their exposure to environment? Like, for instance, Montana. Not sparsely populated, but how is that comparison? Not that particular state. Okay.
I think people are researching things like that, or people research. There are universities and groups that research things like clusters, where in a certain geographic area there seems to be a higher incident. And there is there is research that suggests that the genetic portion of autism, and again, I'm not a biomedical or genetic researcher, but that the genetic basis of autism interacts with environmental factors. So maybe a baby is born with genetic vulnerability that then something in the environment triggers, whether that's sort of nature, the environment, or in utero, some sort of environmental factor. So there really aren't any clear answers, though, about why it's different across different states. And people still do talk about higher incidence in New Jersey because of the density of the population and the density of autism services.
Okay.
So you compare it to one of those Midwestern states, New Jersey is very fortunate to have lots of services for people.
One of the things I want to talk about a little bit is you had talked about graduate students and you had talked about your staff. So explain to me how Rutgers students are involved with the center from an undergraduate level to a doctoral level.
Well, Rutgers students have been at the heart of the DEDC since it was founded. That was actually one of the main reasons, was to create, one, a service for the children on campus, but also a meaningful experience for undergraduates. So not just in a lecture hall learning about the disability, but meeting children with disabilities, their families. So that still happens today. We have 50 to 60 undergraduate fieldwork students every semester who take a class at the DEDC where they spend 1 day a week and they work in a classroom and get assigned to a student or a small group of students, and a teacher works very closely with them. They learn about the disability and the treatment. They can then take a second semester where they get more advanced opportunities. They also then can take a research methods course where they participate in the research that's going on in the center. So hundreds of undergraduates begin their careers in those classrooms and tell us that it's sort of transformative. Like, I met these children and then I realized this is what I want to do. And that's where many of our staff come from.
Oh, wow.
You know, they graduate and they work with us for a few years and continue on in their career. So that's the undergraduate piece.
We have 30 seconds left, so can you tell me graduate students?
Graduate students come in and learn more about assessment and working with the faculty at a higher level.
Much more of a research level.
Correct.
Much more of an intensity level.
Right, correct.
All right,
Yes.
great. Well, you know what? You guys are doing some great work.
Thank you.
And if folks are going to visit your website to learn more about your services, is it ddc.rutgers.edu?
I think so.
All right.
It's going to be launched newly in January. There's a new website coming, so check back.
All right, great. We appreciate that. And thanks for being on the show.
You're welcome.
And thanks for providing us an education on
Thank you very much.
All right. Well, that's all the time we have for this edition of Breakfast at the Barracks. For more information about any of the subjects we've discussed here today, please visit our website at rutgers.tv. For all of us at the Rutgers Division of Continuing Studies, I'm Bill Leipold, and thanks for watching.